grounding lug for electrical metallic tubing, or EMT, is the fitting used to bond a grounding conductor, typically a bare copper wire, to the EMT conduit. It's sometimes referred to informally as a choking ground, but the industry standard term is a grounding lug for EMT. These lugs provide a secure connection point for the grounding conductor, ensuring a safe electrical path. Several manufacturers produce grounding lugs suitable for EMT applications. Here are some examples with part numbers. Firstly, Thomas & Betts manufactures these lugs, and one example part number is MS51. Secondly, Arlington Industries also produces them with an example part number of ETGL. Thirdly, Eaton is another manufacturer with a part number example of GCL. Fourthly, Hubbell Rocco offers grounding lugs, one example being GRL. Fifthly, Ideal Industries manufactures grounding lugs with an example part number of 5124. You can typically find these grounding lugs at most electrical supply stores and from online retailers specializing in electrical components. When installing a grounding lug, the process generally involves these steps. Firstly, insert the grounding conductor, the bare copper wire, into the hole in the lug. Secondly, tighten the screw on the lug to securely clamp the grounding conductor. Thirdly, wrap the tail of the lug tightly around the EMT conduit. Fourthly, firmly tighten the screw on the tail to create a solid electrical connection between the lug and the conduit. This ensures the grounding path. In the 2014 National Electrical Code, which is a widely adopted standard for safe electrical installations, grounding and bonding requirements are extensively detailed. While I cannot provide specific section numbers without knowing the exact application and context, it is essential to consult Article 250 of the NEC for comprehensive guidelines on grounding and bonding. Article 250 covers topics such as general grounding requirements, grounding electrode systems, bonding, equipment grounding conductors, and methods of equipment grounding. To ensure compliance with the NEC, it is always recommended to consult the specific sections relevant to the installation and to consult with a qualified electrical inspector. Remember that proper grounding is crucial for electrical safety, protecting against electrical shock and minimizing the risk of fire. Always follow the manufacturer's instructions and local electrical codes when installing grounding lugs and other electrical components. Electrical metallic tubing, or EMT, serves as a crucial element in electrical systems, providing a protective pathway for wiring while also functioning as an equipment grounding conductor under specific conditions outlined in the National Electrical Code, or NEC. When utilizing EMT as an equipment grounding conductor, it's essential to ensure that all connections are electrically continuous and mechanically sound to provide a low impedance ground fault current path. Grounding lock nuts, bushings, and the aforementioned grounding lugs all play important roles in achieving this continuity. The selection of the appropriate size and type of grounding conductor is determined by NEC Table 250.122, which correlates the size of the overcurrent protective device, such as a circuit breaker or fuse, to the minimum size of the equipment grounding conductor. It is crucial to adhere to this table to ensure that the grounding conductor is adequately sized to safely carry fault currents. The grounding lug itself must be listed for the purpose, meaning it has been evaluated by a recognized testing laboratory and found to meet specific safety standards. This listing ensures that the lug is suitable for its intended application and can provide a reliable electrical connection. When tightening the screw on the grounding lug, it's important to use the correct torque specified by the manufacturer. Over-tightening can damage the lug or the conductor, while under-tightening can result in a loose connection, which can lead to increased resistance and potential failure of the grounding path. The NEC also addresses the use of supplementary grounding electrodes in Section 250.54. While these electrodes are not a substitute for the required equipment grounding conductor, they can help to further reduce ground potential and improve overall system grounding. In addition to grounding lugs, other types of connectors, such as split bolt connectors and compression connectors, can also be used to connect grounding conductors. However, it's crucial to ensure that these connectors are also listed for grounding purposes and are properly installed. When working with electrical systems, always de-energize the circuit before making any connections or modifications. Use appropriate personal protective equipment, such as gloves and safety glasses, to protect yourself from electrical hazards. If you are not comfortable working with electricity, it's best to hire a qualified electrician to perform the work. They have the knowledge, skills, and tools necessary to safely and correctly install grounding systems. Furthermore, remember that grounding is not the same as bonding. Grounding refers to connecting electrical equipment to the earth, while bonding refers to connecting different metallic parts of the electrical system together to create a common electrical potential. Both grounding and bonding are essential for electrical safety. When installing EMT conduit, it's important to properly ream the cut ends to remove any burrs or sharp edges. These burrs can damage the insulation on the conductors, leading to short circuits or ground faults. Use a conduit reamer or a file to smooth the cut ends of the conduit. Also, be sure to support the EMT conduit properly using appropriate hangers and struts. The NEC specifies the maximum spacing between conduit supports to prevent sagging or damage to the conduit. When running EMT conduit through walls or floors, use appropriate bushings or grommets to protect the conductors from abrasion. These bushings provide a smooth, rounded surface for the conductors to pass through, preventing damage to the insulation. In areas where the EMT conduit is exposed to physical damage, such as in industrial settings, consider using rigid metal conduit, or RMC, instead. RMC is more durable than EMT and can provide better protection for the conductors. When installing grounding systems, always refer to the latest edition of the NEC and any applicable local electrical codes. These codes provide detailed requirements for grounding and bonding, ensuring that electrical systems are installed safely and correctly. Ignoring these codes can result in serious electrical hazards, including electrical shock, fire, and equipment damage. To reiterate, grounding lugs designed for electrical metallic tubing, or EMT, are crucial for establishing a secure and reliable grounding connection. They facilitate the bonding of the grounding conductor to the EMT conduit, which serves as an equipment grounding conductor when installed according to the National Electrical Code, or NEC. Several manufacturers produce these grounding lugs, offering a range of options to suit different EMT sizes and grounding conductor gauges. When selecting a grounding lug, it's important to ensure that it is listed for grounding purposes and is compatible with the size of the EMT and the grounding conductor being used. The installation process involves several key steps. Firstly, the grounding conductor, typically a bare copper wire, is inserted into the designated hole within the lug. Secondly, the screw on the lug is tightened to securely clamp the grounding conductor in place, ensuring a firm mechanical and electrical connection. Thirdly, the tail or strap of the lug is wrapped around the EMT conduit, making direct contact with the metal surface. Fourthly, another screw or clamping mechanism on the tail is tightened to create a solid bond between the lug and the conduit. This connection establishes the necessary electrical continuity for grounding purposes. The NEC provides comprehensive guidelines on grounding and bonding in Article 250, covering various aspects such as general requirements, grounding electrode systems, bonding methods, equipment, grounding conductors, and specific requirements for different types of equipment and systems. Consulting Article 250 is essential for ensuring compliance with the NEC and for understanding the principles behind proper grounding and bonding. When working with electrical systems, safety should always be the top priority. Always de-energize circuits before making any connections or modifications, and use appropriate personal protective equipment such as gloves and safety glasses. If you are not comfortable working with electricity, it's best to hire a qualified electrician to perform the work. They have the expertise and experience to ensure that electrical systems are installed safely and correctly. Remember that proper grounding and bonding are critical for protecting people and equipment from electrical hazards. By following the NEC guidelines and using appropriate grounding methods, you can create a safe and reliable electrical system. In addition to the specific requirements for grounding lugs and EMT conduit, the NEC also addresses the general requirements for equipment grounding conductors in Section 250.118. This section specifies the types of conductors that are permitted to be used as equipment grounding conductors, including copper, aluminum, and other materials. It also specifies the minimum size requirements for equipment grounding conductors based on the size of the overcurrent protective device protecting the circuit. When installing equipment grounding conductors, it's important to ensure that they are properly protected from physical damage. This can be achieved by running the conductors inside conduit or other protective enclosures. It's also important to ensure that the conductors are properly supported and secure to prevent them from becoming loose or damaged. The NEC also addresses the requirements for grounding electrodes in sections 250.50 through 250.70. A grounding electrode is a conductive object that is used to establish a connection to the earth. Common types of grounding electrodes include ground rods, ground plates, and metal underground water pipes. The NEC specifies the requirements for the size, type, and installation of grounding electrodes. It also specifies the minimum number of grounding electrodes that are required for different types of systems. When installing grounding electrodes, it's important to ensure that they are properly located and installed. The electrodes should be located in an area where they will be in contact with the earth year-round. They should also be installed deep enough to be below the frost line. The NEC also addresses the requirements for bonding in sections 250.90 through 250.106. Bonding is the process of connecting different metallic parts of the electrical system together to create a common electrical potential. This helps to reduce the risk of electrical shock and fire. The NEC specifies the types of equipment that must be bonded, including metal enclosures, metal raceways, and metal piping systems. It also specifies the methods that must be used to bond these items together. When bonding electrical equipment, it's important to ensure that the connections are tight and secure. This can be achieved by using bonding jumpers or other approved bonding methods. It's also important to ensure that the bonding connections are protected from corrosion. The NEC also addresses the requirements for surge protection in Article 280. Surge protection devices, or SPDs, are used to protect electrical equipment from voltage surges caused by lightning or other events. The NEC specifies the types of SPD that are required for different types of systems. It also specifies the methods that must be used to install SPD. When installing SPD, it's important to ensure that they are properly grounded and bonded. This will help to ensure that they can effectively protect the electrical equipment from voltage surges. In summary, grounding lugs for EMT Conduit are essential components for ensuring electrical safety. They provide a secure and reliable connection for the grounding conductor, allowing fault currents to flow back to the source and trip the overcurrent protective device. By following the NEC guidelines and using appropriate grounding methods, you can create a safe and reliable electrical system. Remember to consult the latest edition of the NEC and any applicable local electrical codes when installing grounding systems. These codes provide detailed requirements for grounding and bonding, ensuring that electrical systems are installed safely and correctly.